All right, so welcome to our presentation. No problem, sir in the front. We're doing Lab as a Service, compose your cloud automatically with a few clicks. I'm Jack Morgan. I work with Intel. Part of OPNFV community. Was the Pharos PTL for the last 2 years, and I run Intel's OPNFV Pharos lab, or have until just recently. We also have one other person who wasn't able to make it, Parker. I can't remember his last name. He is, okay, great. Barbarian. He is a student at the University of New Hampshire and also working on this project. So we'll try to do our best to go through some of his part of the slide, but he is a Lab as a Service developer.
Hi everyone, thank you for sticking around so we are not alone here. Fatih Dermenci, working for Ericsson based in Stockholm, Sweden, and I also work in OPNFV community. I am also an XPTL release engineering project. So as Jack summarized, we will talk about Lab as a Service here. Before talking about Lab as a Service, perhaps it is good to talk about what is OPNFV, why we needed to have this Lab as a Service, because it's about what OPNFV does. And it's about its challenges, which is probably common to many other communities. So we hope that this approach to solving some challenges when it comes to how to enable and empower developers could help others as well. And we can collaborate on this topic further. And what the solution we came up with, which made hopefully some of developers' lives easier, and we hope to make them even better. And then, will you do demo or walkthrough?
Oh, we'll do walkthrough.
Okay,
Like
so you will walk through Lab as a Service. So what is OPNFV? What does OPNFV actually do? So OPNFV is Open Platform for Network Functions Virtualization. It's a very long name, so OPNFV is an open source project which does system integration and testing. What does this mean? So this OPNFV was established about 3.5 years ago to realize the NFV architecture, which was created by HC NFV. I think about 5 years ago, HC NFV released a white paper talking about this NFV and next generation telco networks, which will be built using new technologies such as cloud and virtualization. And in parallel to HC NFV standardization work, some people came up and said, we should perhaps start an open source project that actually tries to realize this architecture by using open source components or open source technologies. And what you see on this diagram is that basically the components we as OPNFV community put together, integrate them, test them, and see if they really work in NFV or telco use cases. And if they don't work, we directly go to upstream communities and get those things fixed or introduce new functionality. So we are an open source integration and testing project which doesn't do too much feature development in its own community, but goes and does that development in upstream communities. And what we do in OPNFV community is basically, okay, we have CI/CD infrastructure stuff, we have test frameworks, test projects, and we also develop test methodology in parallel to HCNFV, and we write test cases if they don't exist in upstream communities, and we try to upstream those test cases as well. And these are some of the communities we work with. So we work with more communities than what you see here. But if I need to give some example about what we actually do, is that as part of our first release, we start with OpenStack, vanilla OpenStack. We didn't do anything. We just put OpenStack on bare metal, and it worked or it didn't work. And then we went to OpenStack and get those things fixed. And again, as part of first release, we this time tried putting SDN Controller in OpenStack rather than using Neutron. We switched to Open Daylight, and this time we create this combination OpenStack with Open Daylight and looked at the combination, it worked or not, and did the same thing this time with two communities, OpenStack and Open Daylight. And over the years, I think we released, this was our 6th release. Yeah, we made 6 releases, and as part of our latest release, Fraser, we had more than 50 different combinations, which is basically, we had OpenStack or Kubernetes, we had Open Daylight, Open Controller or ONOS, we had OVS or FIDO. Also, we had some different orchestration technologies such as OpenO in the past before it got merged with OpenEComp, and now we have ONUP. So we always bring in different pieces of NFV architecture into OPNFV and create those combinations and test them and do the same thing over and over again, basically providing feedback to upstream communities. And the other important thing about OPNFV, which is related to this talk, is that if you look at OpenStack CI/CD, the CI/CD is generally done using DevStack, using virtual machines provisioned from OpenStack via node pool. In OPNFV, we have bare metal labs, and we do our testing as close to reality as possible. So we basically provide production-like environment to the communities we work with. And this results in lots of combinations, because it's not just limited to technologies we are working with, but we have 3 different distributions, Linux distributions. So the first thing we do on our bare metal machines, we provision them with one of the Linux distributions. It could be Ubuntu, CentOS, or openSUSE. And then once the provision is done, we put OpenStack or Kubernetes on top of that. And we don't stop there. This time we do some networking stuff. It could be Open Daylight on OS or OpenContrail in OpenStack case, or it could be different networking plugins in Kubernetes case, like we currently have Calico Canal, Flannel, KubeNet, and as of last week, we added Contiv. So we have all the different networking plugins there, and again, tested. And then we don't stop there. We, this time, try different features. When it comes to OpenStack, we have features like service function chaining or BGP VPN. And those things also impact upstream components, because if upstream components don't support the features that are needed by these different telco features, for example, SFC, we go there and fix them there. And then we come to testing. So we first create the composition or scenario, depending on what the use case we are trying to create and test. And once the combination or composition is on bare metal, then we go and start testing that composition using functional testing, func test project we have, or and platform benchmarking yardstick. And we pick and choose the right case depending on what kind of combination we have there. If we have Open Daylight there, we shouldn't really run OpenContrail specific test case and vice versa. And this, we do this all the time because we are running continuous integration to achieve this. It's kind of almost, or it's totally impossible to create all these combinations and test them. So it is not very straightforward to bring this entire stack up, because when you replace Neutron with Open Daylight or whatever, all these things require special configuration, different parameters, and so on. And when you increase the number of combinations, it really becomes difficult. If you look at CI, yeah, we have the CI doing these things all the time because we created the framework. But this is not a simple thing for developers to do, especially when you look at resource requirements these combinations require. So it's basically, it's very difficult to bring all these different compositions up. And resource intensive, as I mentioned. It is difficult for developers to try or develop all these different compositions. And the other thing, from CI point of view, we have been allocating our resources to different scenarios statically. Basically, we said, okay, you have 2 bare metal nodes, pods, you have 2 bare metal nodes, and you have 2 bare metal pods. But this became a bottleneck over time, and then our CI jobs started queuing up. And when we checked last time, one cycle took 50 hours, so more than 2 days, which is not CI because everything was queuing up, because we didn't really cleverly allocate resources on right things. So we realized that we need to ensure that we utilize our resources correctly and we assign resources dynamically. And the resources I've been talking about come from different community labs we have, and all these labs are donated by member companies. Like in China, we have resources donated by Huawei. In Europe, we have resources coming from Ericsson, Orange. And in US, we have resources coming from Intel. And we have some our self-hosted resources hosted by Linux Foundation. And we use all these resources for CI testing or development purposes. And we have Jenkins master, which sits in the middle, and then we connect all these resources to our CI environment. And last time I counted, I think we utilize more than 200 bare metal nodes, and we run the testing on these nodes. And this is distributed and supported by different companies. And the community labs are taken care of by another project in OPNFV, which is called Pharos. And Jack is the XPTL of Pharos. So.
All right, let me stand over here. So, so Pharos is a project within OPNFV, as Fatih mentioned, that kind of manage these community labs. I think there's probably 16 or so total throughout different places, as Fatih was saying, in the world. And we have different purposes for some of the hardware. They could be dedicated for just CI, they could be testing, or it could be development. They have all different type of purposes. So since OPNFVs might be a little bit different than what you might traditionally see in OpenStack, kind of go in a little bit, explain what we do in OPNFV. So what we have in our hardware setup, we define in a specification as part of the Pharos project. So we have a jump server, which we use to deploy OpenStack and OPNFV. We have controller and compute nodes, 5 of those for high availability. We have different network setups for lights out management, for admin networks, tenant networks, private networks to do our deployment. And then we connected those to different labs through VPN and then SSH to the different nodes. Hardware can be Intel hardware, it could be ARM. We have at least 32 gigs memory of all of our nodes. We have several disks for the OS, for Ceph storage, and Ceph journaling. So because we have these labs and our hardware resources are somewhat limited, we've traditionally, since we've been part of OPNFV, have assigned these resources to projects in a kind of a static model. So a project will get a pod, so 6 servers, and that'll be theirs. And whether they use it or not, we don't have a lot of visibility to that. So it's not a very efficient way to support our project, OPNFV, and especially when it comes to release time, when a lot of testing needs to be done to support the release. As we find that we have a lot of demand for do testing and the use of hardware resources and not enough hardware resources. So kind of one way to help us solve and fix that problem is our lab as a service. And the kind of goal there was to automate the provisioning and deploying of those hardware resources, who's using those hardware resources in a way that helps us be more dynamic and get a kind of a better use of those resources that we have. And we've actually had this up and running and working in one of our labs. So anybody can go and take this and set this up themselves. So kind of the architecture that we have for Lab as a Service, our user will go to make a request on the Lab as a Service dashboard. That will trigger a deployment, and that will get deployed on some of our hardware. And then once that's finished, some status will come back to the dashboard saying that that's complete. Some tasks will get done. And the user will get emailed, and once the user gets done, gets the email, then they'll be able to VPN and connect into that hardware and start using it. So again, if you have any question anytime, feel free to stand up and use the mic to ask a question. So, okay, our lab that we have for Lab as a Service is in the University of New Hampshire right now, and there's 38 or so Intel servers with lots of memory and hard disks. There are some ARM servers as well with the memory and hard disks. We have 10 gig networking between our certain networks that we have, and then 40 gig interconnects between our switches that we have in the lab. So kind of go into little details of how the deployment works. My notes, okay. All right, so we use this tool called Stackstorm. We'll pull the dashboard and see if there's any deployments that need to be set up. And then sensors will get dispatched to trigger the deployment. And the workflow uses Minstrel. It's just an OpenStack project. Deployment workflow interacts with this tool called Fog and helps the host prepare and get set up. So this is what the dashboard looks like. That user would go to book the resources. So the user can book the operating system that they want, the 3 that we mentioned, which OPNFV installer they would like to use. We currently have 5. What scenario they want to have set up. OPNFV uses scenarios where that would be defined a certain SDN controller, the OS, geez, what else?
It could be Kubernetes.
Yeah, it could be,
or,
right.
Yeah.
And then we sort of have a time limit to use that resources, which is up to 5 weeks currently through our tool. This is what the Stackstorm automation server screen looks like. Nothing really kind of specific to go through here, but if there is an issue or something needs to be looked at, the team that manages the lab can go in here and take a look at the dashboard. So Fog is an open source ghosting tool that is used to put the OS on the servers. It's a feature-rich Pixie wrapper around part clone, which is the next slide. So this is part clone that's used to do the imaging and cloning of the nodes. So once the deployment is set up, then the user account is created, VPN access is set up, any lights out management will be set up for the accessing for the developer, and then they'll get the email notification that it's ready to go for them. Okay. Once they're done using the tool, their accounts will be deleted, the servers will be shut down, and then they'll kind of be made available for the next user of the pod.
Now, I think we have been working with Lab as a Service for quite a while, maybe more than a year. And around end of year, we purchased these servers, and they're all very powerful servers. And then we had to set up a roadmap for ourselves, because when you think about NFV stuff and testing all these different combinations for telco use case, it's really complicated. Like, okay, we want to help our developers who wants to develop NFV features, but before that, we need to help out ourselves to understand how we can dynamically set up these nodes, like, and configure the networking, configure the switches, and put the OpenStack or Kubernetes on top of it. So it's really challenging task, because it needs to be fully automated. We can't just put someone there installing this all the time based on requests that person receives. And based on that, we put this minimal viable product to our roadmap as the first thing, because we don't want those servers to sit and idle until we finish total implementation. And the minimal viable product was to enable developers to book resources based on the operating system or Linux distribution of their liking or of their need. And currently we support openSUSE, CentOS, and Ubuntu, and you can basically go fill the form, and in like an hour or two, you get an email saying your OpenVPN is set up, you have SSH access, and you get a monster server with half a terabyte of RAM and lots of CPUs. And that is up and running at the moment, and our developers are already using this. The next challenge is basically all this. Again, I'm not a network engineer, but like the networking setup is pretty complicated, because all these resources are like put together, like 38 Intel machines, 14 ARM machines, and all these switches underlay, overlay, whatever, all those things. And now we are working with Open Daylight community to perhaps use Open Daylight to solve some of the networking challenges we have. And this will help us to create these pods depending on the request we get. Like, I might go and ask single machine, but Jack might go and ask like 6 machines, which is like Pharos pod with one jump host, 3 controllers, and 2 compute nodes. And the system should be able to take those nodes, allocate them to that user, put operating system on them, and then start installing whatever combination the user developer needs. And that can vary between developers. Like we might end up supporting more than 60 different combinations because that is what we released as part of our last release. And the side benefit, or maybe one of the major benefits, is that we really want to see all our resources, not just lab as a service resource located in UNH, but maybe donated resources as like big pool of resources. And for example, initially when we start the development phase of a new release, people generally work with virtual deployments, and single node is enough for them. And at that point in time, our CI doesn't need that many bare metal resources. But over time, when we come close to release, the resource requirements, resource needs increase for CI, and developers actually start documentation, for example. And then we should be able to offload some of the work CI does to lab as a service resource, so we can basically, kind of, you can see this hybrid cloud, private cloud, public cloud. We offload some work there, we get the work done, and then we release those resources. So it's basically ensuring that we can share these resources between CI and development purposes. The automatic deployment I already mentioned, and the other need our users have is that because we have project teams, and projects have like 5, 10, 15 contributors, and currently we give access to nodes to single user, and sometimes those people might share those credentials with each other, which is not really good and secure, and we want to allow the teams to access those resources. Like as a project team, I need a bare metal pod with 6 nodes. I want my team to go there and use that pod depending on what they need to do, feature development, writing test case, and so on. So the multi-user bookings is another thing. And the other thing, like the deployment takes quite a lot of time, like provisioning might be like 20 minutes. And depending on what OpenStack installer you are using, the deployment time varies between half an hour to 2 hours. And that is basically waste of time. We want to ensure that we can snapshot the existing deployment, and when a same developer comes, we should be able to bring up that deployment from snapshots in minutes, cutting the time even further. So we use the CPU time for useful stuff.
Well, and like one more thing I was thinking too is, we might eventually get this connected to our CI process. So as patches and things come in and need to be verified, and there's hardware that's available to be used, those systems might be able to use to take care of our CI as well.
So this tool is up and running. I don't know. I think you have to be OPNFV contributor to use this. But you can go and play with it and join OPNFV if you like powerful machines and contribute to OPNFV. And we have the details documented on our wiki. And yeah, that was our last slide. Any questions?
So snapshotting is like a future roadmap we're looking to do.
I think Ghost Fog might be used for that purpose. Since Parker has been working on this heavily, we don't have too much visibility about what he might need to use for that purpose. But my guess is Fog, because it's snapshotting the disk image. So we can take disk image snapshot, and then we can flash it back to drives when the request comes.
If you can use the mic, it'd be great, because they're recording it. Thanks.
No, I thought you mean when you say snapshot, you're snapshot the whole scenario. Let's say a user sending a request to build a lab, you snapshot that entire lab.
No,
like the snapshot in this context means snapshotting the entire disk on the nodes, storing them on artifact repo, and when the new request comes in for the same thing.
So you snapshot the bare metal node?
Yeah,
right.
Yeah,
so Fog is like open source tool Ghost, which just images the whole disk.
So you get the whole disk snapshot and stored, rather than snapshotting like VMs, we snapshot the disk.
Right, and the feature for snapshotting is more like as you're wanting to retest a certain point that you had in your configuration and setup, and then again test it like 2 weeks from now, you want to be able to snapshot your current configuration and then save it for later. So it's kind of initial setting up and getting the server ready to use a fog using what you're referring to as snapshot image, and then later snapshotting your setup or testing or configuration that you had already created. It's a future feature. That makes sense.
Other than the bare metal pods, can you request Kubernetes pods?
Yeah.
Microphone. Yeah.
Okay.
Yeah.
Sorry, other than the bare metal pods, can we request like Kubernetes pods?
Kubernetes, you mean?
Yes.
Yeah.
Like Kubernetes is a scenario. So if you want a Kubernetes scenario as part of
That's one of the selection.
Right.
yeah.
So basically, yes.
Yeah. But that's not related to like provisioning the machines. That is the next step in the process to put right scenario on top of it. It could be OpenStack or Kubernetes.
So when you snapshot a bare metal, you just snapshot that disk, or
Yeah.
you entire like what kind of snapshot would that be, like including memories, all stuff?
It's just
Just the disk.
yeah. It's basically like this.
So that's understanding because, like, our colleague Parker, who runs in the lab, right? He went a little more detail, but that's understanding, right? Yeah. Because in that snapshotting again is like to set up the system initially to use, right? To do the disk.
But I think memory and stuff, it will not.
Right.
That's
a future
maybe
feature.
we can add that to backlog. We never
Right.
thought about it because we have lots of things in the backlog already.
So I have a question, sorry. Are you planning to have any GPUs on the bare metal deployments like Grid? Because I know OpenStack needs some specific GPUs to use by Nova if you want to have virtual GPU.
Now that's actually, we have similar situation already today. Like we have some pods in our Pharos labs, they have special hardware like SRAOE, DPDK or whatever, and that could be another use case which we might need to bring that kind of hardware to lab as a service setup. And in order to do that, you need to bring this need up to infra working group, so it goes to.
So I need to send some mails or something?
No, but I think so looking at it technically, it shouldn't be too hard because you just need to be able to get the graphics adapter and put it in the system, and then have a configuration or setup within Lab as a Service to be able to expose that to your VM or be able to use it in your testing. So it's the two different things, right?
The first one is putting the request, and the second one is getting that in use.
Right.
Yeah.
So I think it shouldn't be too difficult to do, but we just, again, like need to raise it up as like a request in the community.
And I have one complaint. Why you don't have UPS on the data centers? Because I have my demo in one of those servers, and they said to me that we had some pretty strong winds last week, so the server went down. So I lost the whole demo, and I shouldn't. So yeah,
Well,
this is a complaint.
I think
we might not have had enough money to buy UPS after those servers.
Sorry, totally forgot
I think
that.
Parker maybe we had the storm,
Yeah, you actually
just
shoot the server.
Just powered up yours, right? Powered up yours.
Okay, thanks.
Yeah. All right, thank you, everybody.
Great talk. I really liked it. One technical detail, why VPN? Why can I not just SSH into the machines? It's kind of annoying a little bit.
Well, it has to depend on the University of New Hampshire's network. So I'm sure they don't want to have a dedicated team, network team, security team to manage that infrastructure, considering it would be on the internet, basically, right? Your setup. But I guess it's potentially possible. It just would depend on whether they would be able to support that or not.
Okay.
Yeah, and like I don't know of any lab that currently would be willing to do that so far.
Our Ericsson lab doesn't have VPN.
Yeah. No, SSH.
Yeah, just SSH.
Oh, really?
Yeah. We trust people.
They don't SSH every server. They have SSH one server, and then from there you can actually go inside the private network.
No, it's because there's only two server, right? All right, sorry.
Arvin, yeah.
So the code is it's public, right?
OPNFV Gerrit Pharos repo.
Okay,
It's available.
so there's and I've talked, we talked about this earlier. There's another very similar solution that's open source, has been for some time. So I guess my question is, as it relates to you guys continuing to go down the path and the roadmap of additional things that you want to do, how flexible are you? Like if someone has already solved a particular use case, I think earlier there was a talk about like programmable network devices, for example. And if the code is not a one-to-one match, they've written, for example, I'm not saying this is what it is, but you've written something in Ruby, someone else has written something in Python. How pluggable or open is the system for if someone has already solved a particular issue that you could just marry in what they've done versus having to create code to facilitate that?
No, the thing is, like, as we have been mentioning, this lab is hosted by University of New Hampshire, and the development is mainly done by students there, Parker and I've forgotten the other guy's name. But we, Sawyer, yeah. We as community create the backlog. So if we raise a need, they come and we break the backlog down, and then we wait for them to implement. I'm sure if we put a backlog item saying that, okay, can we look at what these guys have done? We can perhaps reuse what is there already rather than implementing something from scratch. I'm sure it would happen. We just need to know what that thing is, where it is, some names, contact names, so we can get these guys talk to each other, and then we as community look at what this brings, what benefits it provides, and then I don't think there is a major issue there. We just need to know the existence of it.
Yeah, I mean, I didn't even know about this, but it's, we should get those people talking.
Yeah, again, making people talk.
Yeah, it's in the code is in Pharos tools repo within OPNFV. So if you go to the Git web, you can take a look at it. Yeah. Yeah, and just to add on to what Fatih said, like, yeah, let's say there was like some better tool than the current one they're using, Fog, to do ghosting of the image, like some better deployment model than.
The stuff they've used, it does all that. Like you can image the server,
right.
Store, multiple scenarios,
right.
and just click on it and it recreates it.
Yeah, I think they would be open to doing that. I mean, because again, like we kind of work in our own little community, right? And that's kind of the benefit of coming to something like this. And
the universities too, so
right.
I don't think there would be any issue with them talking and figuring out among themselves.
Right.
Because essentially you could open up, essentially you could probably open up, all the additional resources they have too, because that's like a thing, like they're federated clouds across multiple universities, so they share that pool. So it probably could add in, more resources to in New Hampshire, right?
Right.
Yeah, map more resources to their stuff, possibly.
I have a question for you. When do the colleges go for summer holiday in US? When
they go for summer?
Yeah, because we might lose our students because they are moving to third, whatever level, and they might not.
I'm assuming there's probably like a head professor or something, right? That's overseeing it.
There's a link.
Yeah, but we need to get these developers who develop things up this point with the guys you were talking about, so they can share the info, and then the new students can join to this conversation before summer comes.
Well, what I think would be best is to get the professors who are running. So like there's the lady Kate Key, she's like started Nimbus or something.
Okay, so
big, and
we can
maybe linking up the professors who are facilitating the students' work could help get it done quicker.
Yeah, then I know where you live, so I will come and ask this question.
All right, any more questions?
We have 4 minutes left, and we have beer outside at the hotel, so up to you. You can ask questions and we... Okay.
Last
Thanks,
chance. All right, thanks everybody.
Thanks.